Today we are going to learn an important concept in circles, which is the radical axis. Now, radical axis is very important for problem solving, especially from both mains and advanced point of view. Probably from the board's point of view, we may not get much questions from this concept, but from advanced and also mains point of view, we get too many questions. Okay. So, let us see what this concept is. So, first we can define the radical axis as a locus of a point whose powers with respect to two different circles are equal. For example, let us say we take two circles. Let us say there is one circle here, there is another circle here. Now, if I take any random point, let us say this is my locus point P, I can take it as x1 comma y1. Now, from this point, the power with respect to this circle, if I let us say take this as s equal to 0 and take the second circle as s dash equal to 0, then the power with respect to the first circle is going to be s11. In North India, students study S11 as S1 and students study S1 as T. Okay. So, I will just explain the north and south here. So, S which is representing the curve is same for both north and south, but S1 in north is same as S11 in south, and T in north is same as S1 in south. Okay. So, here we are using one particular notation, we will continue that notation. Okay. So, S11, this is the power with respect to the first circle, and also the power with respect to the second circle will be S dash 11. These two must be equal. So, if these two are equal, then whatever is the locus of that point that we get from this will be the radical axis. That is the definition. Now, will this radical axis be a straight line or will it be a curve? That depends on the algebra. Okay. So, if we take the equations only in the standard form, you know the standard form of circle. I will just take the next slide for explaining this. Suppose if I take S as x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. Here standard form must have coefficient of x square and y square to be equal to 1. Only then it is called as standard form. For example, let us say if I have another equation which is 2x square 2y square plus 4g2x plus 4f2y plus 2c2 equal to 0, then this is definitely not in the standard form of circle. Now, to apply the idea that we have written earlier, we have to convert this into the standard form. So, the standard form looks like x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Now, how did we arrive at this standard form? By dividing the entire equation with 2. So, when I divided this equation with 2, the coefficients, the leading coefficients of x square and y square have turned out to be 1. Now, this is in the standard form. We can take this as S dash. Now, when we subtract these two, we generally get the equation of the radical axis. Also, you can observe when we subtract these two, we get x square and y square to be cancelled, and then whatever are the remaining, they will be linear terms only x term, y term and constant are remaining, which means the locus is going to be a straight line. In general, if we subtract one circle from the other circle, we get a straight line, and that is clear and cut. Okay. Now, let us go back. So, here powers of two circles, power of a point with respect to two circles must be equal. That means this equation will give us the equation of the locus. Now, at the end, in the standard approach of the finding locus, what we do is, first we assume the locus point to be x1, y1, and then we apply the conditions, and at the end we replace x1 with x and y1 with y, which will make this equation into a new form, which is s minus s dash equal to 0. So, that means here basically we are subtracting one circle from the other circle. So, this way we can get the radical axis of those two circles. I hope this is clear. Now, definition of radical axis says power of a point with respect to two circles must be same. Based on that idea, we have generated an equation for radical axis. Okay. Now, coming to this, the equation of the radical axis. So, there is a slight mistake here. The equation of the radical axis of the circles must be this, s minus s dash equal to 0. So, which we have proved from the definition itself. Next, the radical axis is a straight line perpendicular to the line joining centers. This we will observe on geometry. Okay. That we will see in the next slide. So, let me erase all of this. Suppose let us say I have one circle here, I have another circle here. Now, if I join the centers, I get a line joining centers. Now, whatever is the radical axis, it will be perpendicular to the line joining centers. Now, will this radical axis bisect the line joining centers? No, it is not. It may bisect in some special cases, but not here. Okay. So, to understand that, we also have to understand the geometrical definition of this radical axis. Okay. For that, keep following this. Suppose let us say I have taken the point here. Now, from this point, let us say I draw a tangent to the first circle. This will be the tangent, and similarly from this point I draw a tangent to the second circle. Now, the lengths of these tangents become the root of the power, which is root of s11, assuming that this is s equal to 0 and this is s dash equal to 0. So, then length of this tangent also becomes s dash 11. Now, if the powers with respect to two circles are equal, then that means these two lengths must also be equal, because whatever are the expressions inside the square root, they are carrying the same values. So, which means these two lengths are going to be equal. So, in a way we can say that radical axis is the locus of a point from which tangents of equal lengths can be drawn to two different circles. Okay. So, that means from any point on this radical axis, if we draw tangents to two different circles, then they will be of equal lengths. So, from any external point to a circle, two tangents are possible. So, here all these four tangents will have equal lengths. This is the logic. Okay. So, if we observe some points, so here the radical axis of two intersecting circles is their common chord. This we will observe little later. Okay. So, till here I hope it is clear. Okay. So, now let us take few cases. So, here what happens to radical axis if the circles are intersecting, if the circles are touching, or what happens to the lengths of the tangents. So, these are three important points which will help us in solving problems. We will observe all of them with clarity. So, now if we check the last one, the lengths of the tangents from any point on the radical axis to the two given circles are equal. This we have observed from the definition itself. Okay. Now, let us observe these 2 points. If we have, let us say, 2 circles which are apart, this is one case. We can have circles which are just touching each other. These 2 circles may not have equal radii, they may be different also. We can have a case where circles are intersecting. Now, please excuse my drawing here, the circles are not exactly looking like circles. Now, here if we observe, the line joining these 2 points can also be called as common chord. This is the common chord, because the chord AB is common to both of them. So, AB is the common chord, but algebraically when we look at the equation will give you the equation of the entire straight line, whether it is line segment or you have taken one ray out of the line, you will get the same equation. For example, let us say there is one line here. So, if you take it from here to here, only this line segment part, and if you look at that algebraically, you will get the same equation of the entire line. Or from this point, let us say you have taken a ray going in this direction, then also you will be getting the same equation algebraically. So, sometimes by looking at the equation, we cannot tell whether the locus is a straight line or a ray or a line segment. For that you may need support of geometry, but here looking at this, equation of AB and equation of this line will be same, which is basically the radical axis. Also looking at this case, when circles touch each other externally, then the common chord here that we get will be the radical axis. Now, we can also get a case where circles touch internally, one circle lying inside, but still they are touching, then also the common tangent that we get here will be the radical axis. But here in this case, we may get few more, in fact 2 more common tangents which are direct, which may be looking like this. So, these 2 tangents we do not get by calculating radical axis. Through radical axis only we get this tangent which is common to both of them. And for the circles which are apart, the radical axis will lie between both the circles, but it will not bisect the line joining centers. Okay. So, this is basic general knowledge of the radical axis. If you want, you can take a snapshot, I will take a water break. So, now let me remove all this and check the points again. Radical axis of 2 intersecting circles is their common chord, that we have understood, and also radical axis of 2 touching circles is their common tangent. Here when we say 2 circles are touching, they can be touching internally or they can be touching externally. For both the cases it is valid. Now, lengths of tangents must be equal if they are drawn from the radical axis, from any point on the radical axis. Okay. Now, let us see other theoretical points. One more point is locus of the center of a circle which is orthogonal to 2 given circles is their radical axis. So, here to understand this, let us take 2 circles. Let us say I have taken one circle here and I have taken another circle here. Okay. Now, let us say from a point P, I am drawing 2 tangents to these 2 circles, and let us say these 2 lengths are equal. Now, by taking this length of the tangent as the radius, if I draw a circle, then what happens? I am drawing this circle in red. So, we may get a bigger circle like this. Okay. Now, you see that I have taken the center as the point and this length of the tangent as the radius. Because I have taken the point on radical axis, these two lengths must be equal. So, that is why I have taken this as the radius. Now, you see here that this tangent is already perpendicular to the radius of this center. Now, if we draw that radius here, this radius will act as tangent to the next circle and the radius of this circle will act as tangent to this circle, which means they are intersecting at this point at 90 degrees at right angles. If two circles intersect at right angles, then we say that these two circles are intersecting orthogonally. Similarly, here also these two circles intersect orthogonally. So, overall conclusion is that from any point on radical axis, if I draw the lengths of tangents and by taking that as radius and the point on radical axis as center, if I draw any circle, it will be orthogonal to the two given circles, or the vice versa. If there is any circle which exists, which is orthogonal to two given circles, the center of that third circle must be lying on radical axis. Okay. So, here we have understood this point in depth. Now, for problem solving, let us say if you are given two circles and if you are asked to find the third circle which is orthogonal to this and a condition is given, then you can straight away take the radical axis of these two circles and on that radical axis you can take the center and finish the problem. Okay. So, this way we can also proceed with problem solving. Okay. So, during the explanation of each theoretical point, if you feel like taking a snapshot, take a snapshot so that we get some space for writing. Okay. Can we move on? So, next point, radical axis of two equal circles is the perpendicular bisector. So, suppose let us say we have one circle here and another circle here. Two circles are said to be equal if their radii are equal. If both of them are having same radius, then we can call that these two circles are equal circles. Now, if I have equal circles here, then the radical axis will pass through exactly the midpoint. Okay. Also, if we draw tangents to both circles, then these two tangents also will be of course equal. So, if we extend the line joining centers, then these will be forming one isosceles triangle. Okay. So, because of the symmetry, we can say that this line is always going to be perpendicular bisector of the line joining centers. This happens only if these two circles are equal circles. Okay. If they are not equal circles, then it is radical axis is not a perpendicular bisector. Also, if you have this misconception, I am also clearing that. Suppose let us say there is one small circle, there is one bigger circle. Now, radical axis is definitely going to lie between these two circles and it will be perpendicular to the line joining centers, but radical axis does not divide the line joining centers in the ratio of R1 is to R2, it will not divide. Okay. So, let us clear it from the beginning only. Okay. So, these are few important points that you can use for problem solving. Next, if two circles of radii R1 and R2 touch each other, if two circles, then this is very straightforward point. Let us say there is one circle here, there is another circle here. Now, if I join the centers, then definitely one radius is R1, other radius is R2. So, the point which is P here, through which the radical axis passes, because we know that radical axis is going to be the common tangent. Now, this P divides these two centers A and B. So, P divides the line joining centers in the ratio R1 is to R2, which is pretty obvious, you can make it out from the diagram itself. Okay. Now, we will move on to the next theoretical point. So, there is a concept called as radical center. Okay. Now, how to define radical center? If there are 3 circles, let us say there are 3 circles. Now, for every 2 circles of these 3, there exists one radical axis. So, if you make pairs like that, out of 3 circles, you can make 3 pairs, circle 1, circle 2, 2, 3, 3, 1. Now, for each pair, we will get one radical axis. So, let us draw a diagram and see. Let us say there are 3 circles like this. Now, for each pair, we will get one radical axis. I will draw the radical axis in blue. So, we will have one radical axis here, we will have one radical axis here, and we will have another radical axis for this pair, which will also pass through the same point. So, basically here 3 radical axes that we got for each pair are going to pass through one single point, which is called as the radical center. So, in a way we can say that radical center is the point of concurrency of 3 radical axes we got for 3 circles. In general, if these 3 circles are not lying on a straight line, let us say if the centers of these 3 circles are not collinear, then all 3 radical axes must meet at a single point. Now, if centers of these 3 circles are lying on a straight line, for example, let us say we have a straight line, and on this there is one center, there is one circle, another center and another circle. Let us say there is another center and third circle. Now, here we will get 3 radical axes, all of them will be perpendicular to the baseline that we have drawn here, which means those 3 will be parallel lines, they will not intersect. Okay. So, only for this case the radical axes are not concurrent, for all other cases they are concurrent, and the point of concurrency is the radical center. Okay. Now, also if you apply the concept, of the orthogonal circle on this, what happens? So, let me take a different color now, I will take black color. Now, from this radical center, if I draw tangents to one circle and also to the other circle and now to the third circle, all these 6 tangents will have equal lengths. All these 6 tangents will have equal lengths. Now, using the similar idea that I have explained with 2 circles, if I take the same length of the tangent as radius and if I draw a circle, that circle is going to cut these 3 circles orthogonally. Wherever I have drawn the tangents, at the points of tangency, the 4th circle will cut all 3 circles orthogonally, that means at 90 degrees. It is always a standard property of the radical axis. From any point on the radical axis, by taking length of tangent as the radius, if I draw a circle, it is orthogonal to 2 given circles. Now, here this point is common to all 3 radical axes. So, that means by taking that as the center and length of the tangent as radius, if I draw a circle, it must be orthogonal to all 3. Okay. So, suppose if question comes based on this, and if 3 circles are given, if equations of 3 circles are given, and if you are asked to find the center of the 4th circle, which is orthogonal to the 3 given circles, then you can calculate it using this concept. Okay. So, let us see few more theory points. So, here there is also one simple idea. So, I am just taking a quick recap. If there are 2 circles, these 2 circles may touch or may intersect or one may lie inside the other, or they can be apart also. In all the cases, radical axis exists. Now, from any point on the radical axis, if I draw tangents, they will be of equal lengths. That means, if I want to find any circle which is orthogonal to these two circles, then what is the best way? Take the center of the third circle on the radical axis and solve the problem. Now, if there are three circles, if I want to find a circle which is orthogonal to all three, then what is the best way? First, get radical axis. Any two radical axes would suffice. Now, by solving those two radical axes, you will get center. Find the length of the tangent, that will give you the radius. Okay. So, this way we can proceed. Okay. Now, we will look at some interesting problems. So, here two circles are such that both pass through a point A comma B. This is one information. Okay, so I will mark the information in red. This is one information. And both touch x axis and y axis, and they intersect orthogonally. Then find the value of this. So, how do we proceed? Okay. So, to solve this, first we have to understand how to interpret this data. So, as I keep saying always, beta, everything is about data. So, you should be able to interpret the data correctly. Okay. So, here if we just check the second point, which says both circles touching x axis and y axis. Now, if we take one sample of a circle which is touching x axis and y axis, let us say there is a circle which is touching x axis and y axis. So, here this y axis is perpendicular to the radius at this point of contact, and also this x axis is perpendicular to the radius at this point of contact. So, here we will get two right angles, and also x axis y axis are already making a right angle, which makes this a square, which means all sides are equal. So, if I take coordinates of center as h comma h, then radius also will be h. This is going to be sure. Okay. So, that is the first idea that I deduced from point number 2. Okay. So, I used the data from the point number 2. Now, I will use the data from point number 1 also, but before that we can in general write equation of circle in this form, which is x minus h whole square plus y minus k whole square equal to r square. This is the general form of circle where h comma k is the center, r is the radius. But in this specific case, because center is h comma h and radius is also h, we can use h for y coordinate of the center and also h for the radius. Okay. Now, coming to this, is h positive, is h negative? That may vary, but here it is given that there is one more third point which is a comma b, through which the circle is passing, and where a is greater than 0, b is greater than 0, which makes the point a comma b to be lying in the first quadrant. Now, if a comma b is in the first quadrant, then circle must lie in the first quadrant, which will make our h to be positive value. So, because a comma b is in the first quadrant, we conclude that h must be positive. Now, sometimes h can be negative also. Sometimes when the information is not so conclusive, we may have to take the circle in the third, fourth quadrants also. Okay. It can be anywhere. So, here now if I simplify, I will get equation of the circle. Okay. So, when I simplify, I got this equation of the circle. Now, after this, I have to make sure that first data is also presented here. So, it says circles have to pass through a comma b. Okay. So, if I substitute here, I will get one condition in terms of A and B and H. So, I will get something like A square plus B square minus 2HA minus 2HB plus H square is equal to 0. Okay. Now, look at this equation. In this equation, A and B are constants. So, here also A and B are constants, but H is parameter that I have introduced. H was not given, I introduced it. Now, here in the problem, two circles are such that they are satisfying these conditions. Now, because both circles are touching x and y axis, both can be represented using this form, but H, the value of H here should have two solutions to represent two different circles. So, that means here for H from this equation, if I try to solve, for H there should be two solutions. So, here we got a quadratic equation in H. Now, if I solve it, I will get two solutions for H. If I name the solutions as H1 and H2, then I will be getting two different circles for these two values of H. Okay. So, let us say I take the solutions here as H1 and H2. Now, after this the problem is going to be cakewalk. So, just think about it, I will take a water break. So, from this I am supposed to get two solutions for H. Now, I will just take the complete workout in the next page. So, the equation I got was this: H square minus 2H into A plus B plus A square plus B square is equal to 0. This is the equation I got. From this I will get two solutions, H1 and H2. Now, if I apply the sum of the roots and product of roots formula, I will get H1 plus H2 as 2 into A plus B and H1 H2 as A square plus B square. This is the information that I deduced based on H1 and H2. Okay. Now, if we look at the equation of the circle here, the circle was looking like this. Okay. Now, if I take two circles, my first circle will look like this: x square plus y square minus 2h1x minus 2h1y plus h1 square. This is my first circle, and if I write the second circle, it will have h2. Okay. Now, third data, it says they intersect orthogonally. Now, what is the condition for orthogonality? That we learned in the last lecture. The condition for orthogonality is 2 into G1 G2. Okay, here G1 is minus H1, G2 is minus H2, and similarly 2 into F1 F2 is equal to C1 plus C2. So, if I simplify this, I got a relation like 4 into H1 H2 is equal to H1 square plus H2 square. Okay. Now, I am interested in finding A by B and B by A. So, that means I have to somehow convert this equation into an equation in terms of A and B. For that, this relation is going to help. Okay. See, if we are already trying to solve for H1 and H2 directly, then finding the solutions of H1 and H2 will complicate the workout. So, we will bypass solving for H1 and H2 by directly linking these two. Okay. So, that means from here, if I calculate H1 square plus H2 square, okay, I will directly convert this only. So, RHS can be simplified as H1 plus H2 whole square minus 2H1 H2. So, which means here I am getting a relation like H1 plus H2 whole square equal to 6 H1H2. Now I will directly put them here. So here I got 4 into A plus B whole square is equal to 6 into H1H2 is A square plus B square. Now I have to somehow connect this to the required form. So what I will try to do is I will convert this also into A plus B whole square, or I can break this, it does not matter. So I will break LHS. So here I will get anyways 1 2 is getting cancelled, so I will cancel it and write the remaining. So 2 into A square plus B square plus 2AB is equal to 3 into A square plus B square. So we got a relation like, if we cancel out the A square plus B square and write the remaining, I will get something like A square plus B square equal to 4AB. Now if I divide with AB on both sides, I will get the required relation. So it says A by B plus B by A is equal to 4. So the required value is 4. Now if we look at the problem workout from the beginning, from the data we have generated one standard form of circle. Okay. See, always explaining a problem takes lot of time, because teacher is also trying to induce a thought in your mind. Okay. But solving this will not take so much time, because the moment after you read the question, if you have this in mind, then you solve it very fast. Okay. So first we generated one standard form of the circle, and two circles are supposed to exist. So I incorporated that two different circles in form of H1 and H2, and then I got a relation in terms of H1 and H2. Here I applied the condition for orthogonality, then I eliminated H1 and H2. That is it. That is the overall plan of the question. Okay. Now we will move on to the next problem. So please take a snapshot, then we will move on to the next problem. Next problem is, two circles intersect at 2, 3 and the slope of their radical axis is 3 by 2. BP and BQ are the diameters of the circles, then find the equation of PQ. Okay. This problem can be solved directly using pure geometry. So I will just solve it here. Suppose let us say we have two circles. Two circles. These two circles are intersecting at A and B. Now point A is given and this point is point B. Now through B, one diameter has to be drawn to one circle and other diameter to other circle. So here there will be a center. Okay. So if I join B and the center, I will get one diameter here. If I join B and the second center, I will get another diameter here. Okay. So this is let us say BP and this is let us say BQ. Okay. Now the centers I am taking them as D and E. Okay. Now we are interested in the equation of PQ, equation of PQ. Now what is the best way to find the equation of PQ? Here if you observe geometry, you may find some interesting things. For example, let us say if I join this AB, then AB will become my common chord. Now the midpoint of this common chord will lie on the line joining the centers. If you join the centers, whatever is the line that joins the centers, that is going to bisect the common chord. This will always happen. When two circles are given, whether they are intersecting or not, whether they are lying one inside the other or not, the line joining centers will always break the entire system into symmetry, two symmetric halves. Okay. So, there is a line of symmetry when it comes to system of two circles. Okay. So, now if the common chord is there, then it is going to be of course get bisected by the line joining centers. Now, here I will draw this line using a different color. Let us say I am taking blue. Now, this line is bisecting the common chord into two equal halves. Also, the point E is already bisecting the diameter BQ in two halves. Also, the point D is bisecting the diameter BP in two equal parts. So, which means here this line DE is actually bisecting all three lines which are passing through this. So, which would imply that if I join P and Q, it will pass through A and it will maintain the same similarity. Okay. So, here basically we are applying the theory of basic proportionality theorem that you have learned in 8th standard or 9th standard. See, if you observe this triangle, this D and E is joining the midpoints of the two sides, and we know that it will be exactly half of the side, and also it will be parallel. So, it will divide the entire triangle into two similar triangles. Okay. You know this idea, which must make the A to be lying on the line PQ. So, which means that PQ must be perpendicular to the radical axis. Okay. So, here the situation went like this. Let us say there is a triangle, and if I join these two midpoints, then definitely this line is parallel to the base and it is half of the base. It is very clear. But this is our old idea, but here our luck was that the chord was bisected by the same line, which means A also must lie on the base. Okay. So, there was one more line which got bisected by this line. So, which made the point A to be lying on the PQ line. Okay. So, now with this geometrical conclusion, we just got the idea that equation of PQ is going to be perpendicular to this chord, so and passing through A also. So, we just use the point and we have to reverse this slope for perpendicular nature. Okay. So, take a snapshot of this, we will solve that question in just a minute. Okay. So, to solve the problem, we just have to take this was our point A, this was our point B. Now, the slope of this line was given to be 3 by 2. Then the slope of the line which is perpendicular to the AB chord will be given by minus 2 by 3, because you know that M1 into M2 must be equal to minus 1. And point A is given, so you can straight away get the equation of the line required. So, y minus 3 by x minus 2 is equal to the slope. Now, when you simplify this, you will get the answer. So, that is it. So, if we simplify this, we get something like 2x here, 3y here, 9 plus 4, 13, minus 13 equal to 0. So, this is the equation of the line required. Okay. So, here the situation was directly a fit into the existing ideas of basic proportionality theorem. So, we just solved it just like that. Okay. Okay. So, we will move on to the next question. Here, if circles touch each other, then, so when two circles touch each other, then what happens? You might have already learned this idea. When two circles touch each other, then the distance between these two circles must be equal to the R1 plus R2. So, D must be equal to R1 plus R2. Okay. So, if we apply this condition, we will get the required condition in terms of G1, G2 and F1, F2. Okay. That is one idea. Now, second idea is here, because these two circles are already passing through origin. Now, how did I conclude that? Because the constant term is not there. Because constant term is not there, then that means these two circles must pass through the origin. Okay. So, if I subtract one circle from the other circle, I will get a radical axis. Then I have to prove that distance of the centers from that radical axis is equal to the radius. That means they are not touching each other. If I apply that condition also, then I will get the required condition. So, method 1 is applying this condition. So, when I take the center of the first circle, let us name it as, let us say C1 will be minus G1 comma minus F1, and radius of first circle R1 will be root of G1 square plus F1 square. Similarly, center 2 will be minus G2 comma minus F2, and radius 2 will be root of G2 square plus F2 square. Now, when we apply this, we will get a relation like R1 plus R2, that means root of something plus root of something equal to distance between these two, which is like root of G1 minus G2 whole square plus F1 minus F2 whole square. Now, we have to square these two and get a relation between G1, F1, G2, F2. But this is going to be a longer process because of the square roots involved. Now, when square roots are involved, what is the best way of getting rid of the square roots? By squaring them. Now, when we square this, the equation, the workout is going to be little long, only little, because when you square this, the terms, most of the terms may get cancelled also. Okay. So, that way you can simplify it. The other method could be to use the idea of the radical axis and prove that radical axis is a tangent. Okay. So, two ideas I have given, you can work out using these ideas. Okay. But for first idea I have worked out a little bit, for second idea also I will work out the equations and leave that to you. Okay. So, if I will just work out for the second idea. So, these are the options. So, let us work out for the second idea. So, here if I subtract one from the other, I will get radical axis as RA. If I write RA stands for radical axis, I will get G1 minus G2 into X plus F1 minus F2 into Y is equal to 0. Now, this must be the common chord or the common tangent of the circles, but because here circles are just touching each other, that means when I solve the same line with any one of the circles, I must not get the second solution, I must get only unique solution. So, let us say from here I substitute for y. So, what do I get if I substitute for y? X square plus, in place of y, I will write G1 minus G2 whole square by F1 minus F2 whole square into X square. So, I have solved for y here and I am substituting here. Okay. Now, plus 2G1x minus 2F1 into, for y I am substituting. So, it will be minus G1 minus G2 by F1 minus F2, but already I put a minus sign here. So, it is managed. So, this must be into x equal to 0. Now, for this equation we must get only one unique solution. Okay. So, that means I already see that there is one factor which is x, which is coming common. Okay. So, suppose if I take x common from here, so I will get x into 1 plus G1 minus G2 by F1 minus F2 whole square plus 2G1 minus 2F1 into G1 minus G2 by F1 minus F2, this is equal to 0. So, there are two factors. Now first factor equal to 0, that is the point which is common to both of them, which is the origin. Now if they are only touching, then that means we should not get the second point, we should get the second point as the first point only. So from here also I should get x equal to 0. So here x equal to 0 is possible only if this constant term is 0. So when I equate this to 0, I will get the required condition. Okay. So when I equate this to 0, what do I get? G1 into F1 minus F2 is equal to F1 into G1 minus G2. So now if I simplify it, I will get G1 F1 get cancelled. So G1 F2 is equal to F1 G2. So this way we can get the condition for required term. Okay. So this is one way of solving the question. You can take a snapshot, I will take a water break. So now we check the answers. G1 F2 minus G2 F1 equal to 0. So option C is the correct option. Okay. So if we erase all of them, option C is the correct option. Okay. So always there could be different smarter ways of solving. So try to think of the methods which will take less time in executing. Okay. Next. Find the equation of the circle on the common chord of the circles as diameter. Okay. So we have to find an equation of the circle which is having the common chord as the diameter. So that means let us say there are two given circles available, let us say these two circles, this is S equal to 0, this is S dash equal to 0. Now we are getting a common chord here. Okay. Now having this common chord as the diameter, there will be another circle which is third circle, and here we want to find the equation of the red circle. Okay. So what is the best way of finding this? One idea is, because this radical axis is acting as a line, I can take any one circle. I can take any one circle first, which is the S equal to 0, take the line which is let us say L equal to 0. This L equal to 0 line is same as the radical axis. Now if I apply the concept of family of lines here, so S plus lambda L equal to 0, this equation of circle represents all circles passing through these 2 points. There will be many circles, there will be infinite circles passing through these 2 points, but this equation will represent all of them. So lambda being a real parameter, if I vary lambda, it will give me all circles passing through those 2 points. Now out of those infinite circles, I want only one circle which has that line itself as the diameter, because that line is the common chord here. Okay. So this is my plan. So how do I execute this plan? Okay. So to execute this, what I will do is, I will take the radical axis first. So to get the radical axis, I have to subtract one equation from the other equation. Okay. So if you want to take a snapshot of the plan, take a snapshot right now. Okay. So now I will start working. This is my common chord, this is my first circle, this is my common chord. So using these two I am making, and my red circle is going to be something like this. This will have the radical axis as the diameter. Now radical axis can be calculated directly by subtracting one circle from the other. Okay. So now you imagine that x square y square terms are same. So when I subtract them, they will get cancelled. So let me just do that for you. Now when I subtract, I get 2x plus 1 equal to 0. So this is going to be my radical axis, which is also my L equal to 0 line. Okay. So here I can take the family of equation like this: x square plus y square plus 2x plus 3y plus 1. This is my S, that is the first equation of the circle, and after this lambda into the line, which is 2x plus 1 equal to 0. Now if I simplify this further, I get x square plus y square plus, if I take x common, I get 2 plus 2 lambda. Now if I take y common, I will get only 3 here, and plus lambda is equal to 0. This is the equation of the circle in family form. It represents the family of circles passing through those 2 points, which are ends of the common chord. Now I want that line only to be the diameter. So that means the center of the circle that I got in terms of the family, the center of this family circle must lie on the radical axis. Okay. So for that I will just calculate center from here. Center is minus 1 minus lambda comma minus 3 by 2. Now this center must lie on the same radical axis for the common chord to be the diameter. For the common chord to be the diameter, the center of the family must lie on the common chord only. So which means I have to put this center in the radical axis and get the lambda. Okay. So if I put the center in the radical axis, then I will get something like this: 2 into minus 1 minus lambda plus 1 must be 0, because there is no y coordinate here, I have just substituted the x coordinate. So which will give me minus 2 plus 1 minus 2 lambda equal to 0, which will be like lambda equal to minus 1 by 2. So now when I substitute minus 1 by 2 in this equation, I will get my final answer. Okay. So the answer will be like x square plus y square plus x into, for lambda I have to substitute minus 1 by 2, which will give me 1 here, plus 3y minus 1 by 2 equal to 0. So this will be the answer. Okay. So here if we observe, what we did was, we initially drawn a diagram. This is your standard algorithm of solving questions in coordinate geometry. Your first step is to understand the given data, draw a diagram, make a plan. If your plan is good, if your plan is till the answer, only then proceed, otherwise do not proceed. Okay. So this is how we solve the question. Okay. We will move on to the next question. Find the equation of the circle which cuts the circles orthogonally. So here if you observe, it is typically on the concept of 3 circles. Okay. So here we have 3 different circles given, and we have to find the equation of the circle which will cut the given 3 circles orthogonally. So what is the plan? So let us work out the plan geometrically. So we have one circle here, other circle here, other circle, 3 circles. Now if I find the radical axis of these 2 circles and also these 2 circles, they will intersect at a point. The third radical axis also must intersect at the same point. That will be our center of the circle, which is orthogonal to the 3 given circles. Which means to get this center, I can just get any 2 radical axes and solve them. So that is my first step, get the center. Now from the center, if I draw tangents to any one of these circles, let us say in red I am drawing tangents to any one of these circles, then all these 6 tangents must be of equal length. That is the definition of the radical center. Okay. Now by taking this length as the radius, if I draw a circle, it will cut all 3 circles orthogonally. So which means I just have to find this length of the tangent, which will give me radius. So get 2 radical axes, solve them, get the center. After getting the center, in any one of the equations of the circles, put the point and get the power, that will give you length of the tangent, and that is also same as the radius. If you have center and radius, you got the circle. That is the plan. Okay. Now, we will work out this plan. So, first I will subtract second circle from the first circle. Okay. So, we name these circles as, let us say this first circle is 1, this circle is 2 and this third circle is 3. So, now 1 minus 2 will give me 6x minus 4x, which is 10x. This is x, and 2y minus y, it is 3y. 1 minus 1, which is 0. So, this is equal to 0. This is my first radical axis. Now, I will take next two equations, 2 minus 3. X square y square will anyway get cancelled, minus 4x plus 4x. So, we have to subtract the second 4x from this. So, we get minus 8x. Also here minus y and here minus 2y. So, when we subtract, it becomes plus y, and constant terms are same in these two circles also. So, we will get equal to 0. So, now from these two we have to solve for x and y. Now, equations have already came in very simplest form, that is both are passing through the origin. So, the point of intersection is the origin, which makes the center of the circle, which is orthogonal to all three circles, is at the origin, which is very simple. Now, we want to find the radius of the fourth circle, that is same as the length of the tangent drawn from the radical center to any one of these circles. So, let us say if I put in any one of the circles, then root of S11 will come out to be, let us say I am substituting in the first equation. So, for x and y I am substituting 0. So, all the terms will become 0 except the last term, which is 1. So, basically S11 is 1. So, this means radius will become 1. If radius is 1 and center is 0, 0, then equation of circle becomes x minus 0 whole square plus y minus 0 whole square equal to 1 square, which is same as x square plus y square equal to 1. Okay. So, this way we can solve the problem. So, here also what we did was, we first made a plan and then we executed our plan. Okay. We will go on to the next question. So, here if ABC are centers of three equal circles, their radical center is dash of the triangle ABC. Okay. So, if we check the options, options are centroid, orthocenter, circumcenter, incenter. Okay. So, we will try to do this with a diagram. Let us say we take two circles here, which are equal. Equal circles means radius of both circles, radii of both circles are equal. Now, if I join these two, let us take the centers as let us say ABC, then we will get the line joining centers. Now, if two circles are having same radii, that means equal circles, the radical axis will bisect the line joining centers. Also, we know that radical axis is perpendicular to the line joining centers, which is always true. Whether circles are equal or not, radical axis is always perpendicular to the line joining centers. So, here that makes this line joining centers and this line perpendicular and also perpendicular bisectors. Okay. So, basically we can take this radical axis 1 as perpendicular bisector of AB. Now, if this point is clear, we have cracked the question. That means, even if I take one third circle, Now, for this circle also the radical axis is going to be perpendicular bisector for this situation also. So, here we already got two perpendicular bisectors. Now, for the next pair also we can repeat the same, then also we are going to get perpendicular bisector only. Now, when three perpendicular bisectors intersect each other, the point of concurrency becomes circumcenter. So, this point of concurrency becomes circumcenter. This is the standard idea of circumcenter. In fact, it is the definition of circumcenter. Circumcenter is the point of intersection of the perpendicular bisectors. Okay. So, which means the answer to this question is going to be the circumcenter. So, here we solve this question using pure geometry and common sense. Okay. Now, let us solve the next question. Here ABC are centers of the three unequal circles touching each other externally, then their radical center is. Options are same, all centers. Out of these, which center is the correct answer? So, let me work out this by taking only two circles first. Now, let us say I have taken one circle here, other circle here. These circles are unequal. Unequal means radii must be different. Now, when they are touching, the radical axis will be the common tangent. The radical axis will be the common tangent. So, here I will draw the radical axis in red. This is my radical axis. Let us say there is another circle which is also touching these two given circles. Now, if I join the centers here, also I think here we have to take bigger diagrams. Okay. So, I will take bigger circles. Okay. So, now the diagram is more clear. Now, when I take the radical axis, this is one radical axis, this is one radical axis. I hope you can get this radical axis. Now, also if I join the centers in blue, we can get centers like this. So, we can take this point as A, this point as B, this point as C. Now, if you observe the point of intersection where these red lines are intersecting, from this all the tangents that I can draw from the radical center, all the tangents that I can draw to three different circles must be equal. So, that means if I take this center as let us say P and this point as let us say D, this point as E, this point as F. So, here by the definition of the radical axis, we get that PD is equal to PE is equal to PF, and these points D, E, F, these points are lying on the sides of the triangle ABC, and also radical axis is perpendicular to the line joining centers. So, PF is perpendicular to AB, PF is perpendicular to AB. So, that means in a way we can say that PF is the perpendicular dropped from point P to the side AB. Okay. So, now by taking this length as the radius, if I draw one circle, then this circle is going to touch all three sides internally. So, that means the radical center of these three circles is going to be in center of the triangle. Okay. So, if they are touching externally, then radical circle, which is the fourth circle here that we have drawn here. So, this is going to be the in circle. Okay. So, in a way we can also learn from this problem that if three circles are intersecting, if three circles are touching externally, then the radical circle of those three circles will be the incircle of the triangle formed by the centers. Okay. Okay. So, we can move on to the next. So, here the answer is going to be in center. Okay. Now, we will move on to the next problem. If you want to take a snapshot of this diagram. Okay. Next problem. If ABC are centers of three mutually orthogonal circles. So, here also it is based on the same idea, but a slight twist is always added. Okay. Now, if ABC are centers of three mutually orthogonal circles, their radical center is which center? Of course, same options. Now, what happens if three circles are mutually orthogonal to each other? Let us take three circles. So, for that let us start with two circles. Let us say we have two circles which are already intersecting orthogonally. One circle here, another circle here. They need not be equal. If it is not mentioned whether they are equal or not equal, if it is not mentioned, then you have to take them as unequal only, not equal. Okay. So, here these two are intersecting at an angle of 90 degrees. Now, what happens when two circles intersect at 90 degrees? The tangents here are at 90 degrees. Now, this tangent to the first circle passes through the center of the second circle, and this tangent to the second circle passes through the center of the first circle. It is always guaranteed. So, now if I join these two, then this radical axis is going to pass through this point. It is going to pass through these 2 points. Okay. Is this clear? Now, also we have this idea that any circle, any third circle which is orthogonal to the two given circles will have its center on the radical axis only. So, if I am able to draw any third circle here which is orthogonal to the two given circles, then the third circle's center must lie on the radical axis, which makes the center of the third circle, here ABC are the centers of three circles. So, which makes the center of the third circle lying on this line only. So, which means we can generate a different diagram here. Okay. So, if let us say there is one point here which is C, and if I join these ABC, now through C I am drawing another circle, by taking C as the center I am drawing another circle which is orthogonal to these two, which will confirm that this radical axis which is already perpendicular to AB is also passing through the third vertex of the triangle, which makes this radical axis as altitude. For example, if I take this triangle, then the point C is one vertex. Now, passing through C and perpendicular to AB, whatever is the line that I get is going to be altitude. So, here it is confirmed that the radical axis I am going to get for each pair of the circles is going to be altitude of the triangle. So, that means three altitudes. Now, the radical center of these three circles will become the point of concurrency of altitudes, which will make the point to be an orthocenter. So, here the answer is going to be orthocenter. Okay. So, this way we can solve these questions conceptually. Okay. Now, let us proceed with another idea. Okay. So, before that, if you want to take a snapshot, take a snapshot. Okay, so can we move on? Also, before we move on, if we just check these three questions are based on the same idea. Three circles are given. What happens to the radical center? Now, if all three circles have same radius, then radical center is the circumcenter. Now, whether circles touch or intersect or they are apart, if all three circles are equal circles, if all three radii are equal, then it has to be one circumcenter. Now, if circles are touching here, so I am just taking a special case, if circles are touching and also equal radii, then that means we will get one equilateral triangle when we join the centers. So, which will automatically make the center as circumcenter only. Okay. In fact, here it is whether in center or circumcenter, it is going to be same. Okay. But if they are touching externally, it is the in center. If they are orthogonal to each other, it is the ortho center. Okay. So, I hope this is clear. Now, if all three circles are equal and if they are intersecting orthogonally, then ortho center becomes circumcenter becomes in center, or the other way, if they are touching, then also ortho center, circumcenter, all three will be same only. Okay. Okay. So, we will move on to the next concept, which is the coaxial system of circles. Okay. Now, what is the meaning of this coaxial system of circles? Here it means, if let us say there is a system of circles, system means a family. Family means it is a set of curves which have same common property. Family of circles means it is a collection of curves, it is a set of curves which have one common property. Because now that I have started this, so I will explain the jargon clearly. Suppose let us say I write an equation like this. So, this means I will get all circles having origin as the center. Now, including the point circle, I can just put equality there. I will get all circles having origin as the center. So, I can say that this is an equation of family of circles. Now, family of curves means it is a set of curves which are having one common property. What is the common property here? Center is same for every circle. Okay. Also, I can write a system of circles like this: x square plus y square minus or plus 2gx plus 4 equal to 0. So, let us say I have taken a circle like this. Now, what does this represent? This represents, see here g is a parameter, all others are constants, but there is only one parameter. Now, if I check the center of this circle, the center becomes minus g comma 0 and radius becomes root of g square minus 4. Now, center is varying, radius is also varying, but what is common here? Center lies on x axis. So, we can say that this second equation represents family of circles having center on x axis. So, this way we can represent equations of family of circles. Okay. Now, here we can also call it a system of circles. Okay. Now, when we write family of any curves, there is one parameter always involved. That parameter represents the common property. Okay. So, here the parameter will be directly linked to the common property. Okay. So, similarly, if I take any one circle as a s equal to 0, if I take line as L equal to 0, now passing through these 2 points of intersection, passing through these 2 points of intersection, if I take all circles, how many circles are possible? Infinite circles are possible. This side also we get lot of circles. All those circles can be represented using this equation S plus lambda L equal to 0. Okay. Now, this represents family of circles passing through the points of intersection of line and the circle. If we name these points as A and B, then this represents family of circles passing through A and B. Now, here if we observe, what is the common property for this family? Common property is passing through A and B. We can also call this as coaxial system of circles, where the system of circles is having one common axis. So, if there is a family of circles which has common radical axis, it is called as the coaxial system of circles. So, here I have explained the meaning of the phrase coaxial system of circles. If there is a system or family of circles which has common radical axis, it is called as the coaxial system of circles. Now, let us see how to put this in terms of equations and what is the standard form of that coaxial system, that we will see in a while. Okay, so, I will just erase all of it. See, the family of circles having common radical axis is called as the system of coaxial circles. Okay. Coaxial system of circles or system of coaxial circles, it is the same. Okay. So, now what is the general equation? What do we take as the general equation or the standard equation? That we will see in a short while. So, here if we look at this, equation of the simplest form of coaxial circles is this. Now, what is the meaning of this? Okay. Simplest form means, let us say I take two circles of this kind. Let us say I take a circle here, x square plus y square plus 2 lambda 1 x plus c1 equal to 0. Okay. And x square plus y square plus 2 lambda 2x plus c2 equal to 0. And if I find the radical axis here, what will be the radical axis? X square y square will get cancelled because we will subtract one circle from the other circle, and then we get something like 2 into lambda 1 minus lambda 2 into x plus c1 minus c2 equal to 0. This becomes our radical axis. Now, to represent or to standardize the equation of the coaxial system, what we do is we assume that y axis is our common radical axis. Now, if I want the y axis to be the common radical axis, then that means when I subtract, I must get the equation of y axis as the radical axis. So, equation of y axis is x equal to 0. Equation of y axis is x equal to 0. Now, I want to get x equal to 0 here, which makes c1 minus c2 to be 0. Okay. So, here the modification that I am doing is this: instead of writing c1 and c2, I am just writing c. Okay. So, now when I subtract, what happens? When I subtract, I will just get this to be equal to 0, which will give me y axis as my radical axis. So, when mathematicians wanted to represent one coaxial system, they took y axis as the radical axis. Okay. So, this is one simplest form. Now, if you are taking x axis as the radical axis, what could be the equation? You can write the equation in similar lines: x square plus y square plus some 2fy plus some constant c equal to 0. Okay. So, here when we look at this c must be the constant term, because when we subtracted, c must get cancelled, and the lambda must be the parameter. Parameter means it is supposed to be a constant for that particular situation, but it can vary. Now, when we vary the parameter, we will get all members of the family. Okay. So, here we have understood the equation first. Now, similarly, if we go for the system which has x axis as the radical axis, Here also C must be constant and this f must be the parameter. So, this way we can design any system. Now, also there is something that you can notice here. For this family, the centers lie on x axis, and for this family, centers lie on y axis. Okay. So, now we can conclude in one single statement like this. So, this is the simplest form of coaxial system of circles, where centers of all these circles is on x axis and the radical axis is y axis. Okay. So, this is the system. I have explained this using the examples. Now, we will look at the other points. Its common radical axis is y axis, we have understood that. Also, this is a different point. Okay. Also, the centers lie on x axis. Now, if C is greater than 0, then it is a non-intersecting system. So, this, to understand this, we will try to derive the ideas using the equation only. Suppose from here if I take the center, it is minus lambda comma 0, and if I take the radius, it is root of lambda square minus c. Okay. Now, here for the circles to exist, okay, for the circles to exist, the radius has to be real. Okay. That is always there. Now, by taking this equation and converting into a different form, x square plus y square plus c plus 2 lambda into x is equal to 0. By converting the equation into this form, we are also converting this into s plus lambda L equal to 0 form. This looks like s plus lambda L equal to 0 form, where L will give us the radical axis, which is same as the x equal to 0, which also supported our system. So, there are always two ways of explaining any idea. One is top to bottom, one is bottom to top. Bottom to top comes from taking examples and working out the way out through examples. The second is straight away hit the equation, convert that into a pattern and then analyze it. Okay. So, there are two ways of understanding it. Now, coming to this, whatever are the intersections of this line and this equation will give us the points of intersection of the circles. For example, when I take s plus lambda L equal to 0, I can get a situation like all circles are touching one radical axis. This situation can also be represented using that equation. So, here if you understand, there are so many circles possible. Okay, there are so many circles possible here. Now, this system can also be represented using s plus lambda L equal to 0. Also, if we take this case, if two circles are intersecting and also there is, let us say, this radical axis, now passing through these 2 points, there will be infinite circles, but all these circles can also be obtained using the same idea. Okay. Now, whether it is touching case or intersecting case, or even if the circles are apart and they are having the common radical axis, we can get many circles like this also. Now, even this case is also represented using the same equation. Now, how to identify whether the given equation represents the touching system or the intersecting system or the apart system? How do we identify this? To identify this, we solve this line and the circle, and based on the number of solutions, we can analyze it. Okay. So, let us analyze that. So, here we got x square plus y square plus c plus 2 lambda into x is equal to 0. Now, this is the circle and this is the line. So, that means if I solve these two, this circle and the line, if I solve these two, that means I have to substitute x equal to 0 here, which gives me y square equal to minus c. So, here if y square has, if y has two solutions, it means there are 2 points at which the system will intersect. If y has only one solution, then that means the system will touch. If y has no solutions, then that system is apart. So, we will take 3 cases, okay. Those 3 cases we will get here. If c is greater than 0, you can see that when c is greater than 0, y square is equal to a negative number, which is an inconsistent equation. So, there are no solutions for y, that means there are no points of intersections. So, which means this represents a system which is apart, okay. Similarly, if c is equal to 0, if c becomes equal to 0, y square is equal to 0, which means y equal to 0. So, x equal to 0, y equal to 0, which is the origin, that is the only common point, which means all of them are passing through only one single point, which is the touching point, okay. So, this gives the touching system. Also, if c is less than 0, then it is an intersecting system, okay. So, if c is less than 0, what happens here? RHS becomes a positive number, then y square equal to positive number will lead to 2 solutions. That means there are 2 points of intersections, which means those 2 circles will cut each other at 2 points. So, in that system there are not just 2 circles, there are infinite circles. But if you select any 2 circles, they are going to intersect at the same points, okay. So, this is the basic idea of the coaxial system of circles, okay. So, in today's lecture, we are running short of time, so I am closing the lecture. So, in today's lecture, we have understood what is radical axis and how to solve problems using the concept of radical axis, and also what is radical center, how to solve problems, what are some theoretical tips and ideas, and what are the problem solving ideas. We have understood all of them, and towards the end we learned coaxial system at basic level, okay. In the next lecture, we will meet with more concepts. Until then, have a great learning day. Learning shall never stop.